In this session, let us go through some more special problems, rather important problems in areas. Let us deal with the problem. The area between y is equal to tan x, 0 less than or equal to x less than or equal to pi by 3, and y is equal to cot x, pi by 6 less than or equal to x less than pi by 2. These are the two graphs, very familiar graphs. The area enclosed between these two graphs and x-axis, that is another. This is the problem. So we have together the two graphs. Look here. Zero. This is y is equal to tan x between 0 and pi by 3. Somewhere else here it is pi by 2. And for cos x, let this be pi by 2. This is pi by 4. Somewhere else here it will be pi by 3. This is cot x. In that region, everybody knows and believes that the two graphs meet at pi by 4. Meet at pi by 4. Our required area is this area plus this area. So it has been split into two pieces. For the first piece, you see what is this graph? Y is equal to tan x. And for this it is y is equal to cot x, isn't it? So required area is equal to integral 0 to pi by 4. From this to this, we are moving under the curve y is equal to tan x, isn't it? Therefore it is tan x dx plus, and from this place to that place, it is pi by 4 to pi by 2, isn't it? Therefore integral pi by 4 to pi by 2, what is this curve? Y is equal to cot x dx, isn't it? Y is equal to cot x. The required area is divided into two pieces. The first piece is from 0 to pi by 4 of tan x, and the second piece is pi by 4 to pi by 2 of cot x. So this is, what is integral of tan x? Log mod secant x to the base c between the limits 0 to pi by 4. And what is the integral of cot x? For cot x, we know that it is log mod sin x to the base c, or ln mod sin x, or simply like this, between the limits pi by 4 to pi by 2. Come on, let us substitute the limits. Secant pi by 4, secant 45, what is that? Root 2. So it is log root 2 minus secant 0. Secant 0 is 1, log 1 is 0. So the first part is log root 2 minus 0 plus, come on, pi by 2. You substitute these limits. Sin pi by 2 is 1 and log 1 is 0. So 0 minus pi by 4. Sin pi by 4, sin 45 degrees is 1 by root 2. Hence it is log 1 by root 2. Log 1 by root 2. Okay, therefore this is log root 2. You see, you can write log 1 by root 2 as minus log root 2, isn't it? So minus log 1 by root 2 is minus of minus log root 2. Hence it is plus log root 2. Log root 2 plus log root 2 is log of root 2 into root 2. That is nothing but log 2. Hence the answer is log 2. Answer is log 2. The next question is, find the area bounded between y is equal to x square and y is equal to 2 by 1 plus x square. Y is equal to x square and y is equal to 2 plus x, 2 by 1 plus x square. We know that y is equal to x square is, of course, no doubt it's a parabola whose axis is y-axis. What about this? Y is equal to 2 by 1 plus x square. Let us first know where does it meet y-axis. It meets y-axis at x equal to 0, that is y is equal to 2 at the point 0, 2. Okay, when can it meet x-axis? In order to meet x-axis, y must be 0. That is 2 by 1 plus x square. It can never be 0. It can never be 0 unless x is infinity. So at infinity only it crosses, rather it touches x-axis. Okay, so we can imagine the graph like this. This is y is equal to x square, no doubt. This is y is equal to x square, and in order to plot this graph, let us first know where do they meet, the points of intersection of these two curves. By knowing that, we can imagine the graph. Look here, y is equal to x square and y is equal to 2 by 1 plus x square meet at x square is equal to 2 by 1 plus x square. Cross multiply. X to the power of 4 plus x square is equal to 2 or minus 2 is equal to 0. And it can be taken as x square plus 2 into x square minus 1 is equal to 0. But you see, x square plus 2 cannot be 0. Why? Because if at all x square plus 2 is 0, x square becomes negative. For real values it is not possible. Therefore, this cannot happen. So what should happen? X square minus 1 is equal to 0. That is x is equal to plus or minus 1. We are happy. Why? Because we could have known the points at which those two curves, those two given curves do meet. Well, therefore, we can imagine like this. So this is minus 1 and 1, you see. The curve will be no, it does not meet x-axis. Just like a dish. Okay, this is minus 1, this is 1. And you can easily imagine the required area. Therefore, required area is integral minus 1 to 1. What is this curve? What is this curve? Y is equal to 2 by 1 plus x square. And this is y is equal to x square. If between these two, which is add, this is add of this. Therefore, integral minus 1 to 1, 2 by 1 plus x square minus x square dx, isn't it? And surely it is an even function, no problem. Therefore, instead of minus 1 to 1, you can write it to be 2 into integral 0 to 1, 2 by 1 plus x square minus x square dx, correct? Yes, of course. So, therefore, it is 2 into 2 4, isn't it? 2 into 1 by 1 plus x square is tan inverse x between the limits 0 to 1 minus 2 into, for x square it is x cube by 3 between the limits 0 and 1. Because this 2 into is applicable for both of these. Okay, so it is 2 2s are 4. What is tan inverse x between 0 and 1? Tan inverse 1 is pi by 4. Tan inverse 0 is 0. Minus 2 into, if you put 1 here, it becomes 1 cube by 3 or 1 by 3. Hence it is pi minus 2 by 3 is the right answer. So many square units. So many square units. No doubt it's a good problem. The special or the main item here is to have the idea to draw this graph. This is important here. You have to imagine, you have to estimate the nature of the graph, unless or otherwise it might not be possible to have the limits of integration. Let us look at the next problem. The area are bounded by x power 2 by 3 plus y power 2 by 3 is equal to 1. These are all standard curves and the standard diagrams. Area bounded by this, we are now ready to have. Well, when does it meet x-axis? X equal to 1. No, x power 2 by 3 is 1, isn't it? X square is 1. X is equal to plus or minus 1. In a similar way, when does it meet y-axis? Plus or minus 1. 0, 1, 0, minus 1. Therefore, the nature of the curve will be minus 1, 1, minus 1, 1. Like this the function will be, the curve will be, because it's famous, everybody knows it, x power 2 by 3 plus y power 2 by 3 is equal to 1. In general, it is a power 2 by 3. In so many problems in our applications of derivatives, we might have come across this function. Okay, come to the point. This is the required area we want. This point is minus 1, 0. This point is 1, 0. This is 0, comma minus 1, 0, comma 1. Come on, you choose. Do you like to have the area along x-axis or along y-axis? Both are correct. Let us choose one aspect out of them. I like to have the area along x-axis. And moreover, I would like to find this area only because basing on the symmetry of the figure, all these four parts comprise the same area. Therefore, the required area is 4 into integral 0 to 1. Enough. I like to have this area first. I like to have this area. Well, required area is integral 0 to 1 y dx, integral 0 to 1. How can you get y from this? Y power 2 by 3 is 1 minus x power 2 by 3. Y power 2 by 3 is this. So y is whole to the power of 3 by 2 dx. Well, my dear, it is not impossible, rather not difficult to have the integral directly, of course. But let us introduce a trigonometric function here. Let me call this I. This is I. Okay, let x is equal to cos cube theta or sin cube theta, as you like it. As you like it, you can take whatever you like. Let x is equal to sin cube theta. Because x power 2 by 3 is present, I introduced sin cube theta. Implies dx is equal to 3 sin square theta into derivative of sin theta is cos theta d theta. Cos theta d theta. Also, now we must change the limits also because we have changed the variable. Okay, if x is 0, sin cube theta is 0, sin theta is 0, so theta is 0. X is equal to 0 implies theta is equal to 0. X is equal to 1 implies, isn't it? These are the old limits. If x is 1, sin cube theta is 1, sin theta is 1, and sin theta is sin theta is 1, hence theta is pi by 2. Pi by. Okay, with these modifications, what will be the shape of our required area? I is equal to, isn't it? We could have made some changes. These are to be implemented here. I is equal to, instead of 0 to 1, what are you supposed to have? 0 to pi by 0 to pi by 2. 1 minus x is sin cube theta. Sin cube theta whole power 2 by 3 whole to the power of 3 by 2 into dx. What is dx? 3 sin square theta cos theta d theta. Well done. 3, go away. It is sine square theta and it is 1 minus sine square theta. 1 minus sine square theta is just nothing but cos square theta. So this is integral 0 to pi by 2. This is cos square theta whole to the power of 3 by 2. 2 and 2 go away, leaving you cos cube theta into 3 sine square theta cos theta d theta. Altogether, you please pull 3 outside. What happens? This is 3 into integral 0 to pi by 2 cos cube theta into cos theta, cos to the power of 4 theta into sine square theta d theta. Well, my dear, that can be simplified by using an application of Wallis formula in integration and definite integration also. I think you could remember we could have called this type of integral as IMN. Here it is I42, isn't it? Let us use that symbolism, that style and that methodology to simplify this. 3 into, so this is I42, IMN. What is the starting step? What is the starting step? M plus n minus 1 or m minus 1 by m plus n. What is m? 4. M minus 1 is first of all 3 into 4 minus 1 is 3, 4 plus 2 is 6 into 1 by 4 into, you cannot decrease 2 further. What should you do here? I02 it becomes. What is I02? I2. What is I2? Integral sine square theta, isn't it? Integral sine square theta. Integral 0 to pi by 2 sine square theta d theta. This is therefore 3 into 3 by 6 means 1 by 2 into 1 by 4 into, what is integral 0 to pi by 2 of sine square theta? Again, Wallis formula, In, n minus 1 by n into I0 is pi by 2. Is pi by 2. Altogether, the total answer is 3 pi by 2 2s are 4, 4 4s are 16, 16 2s are 32, so many square units. The picture is simple. No doubt, the limits of integration you can easily have. You can easily have, isn't it? In the very beginning, it seems that we have forgotten 4. So the required area is 4 into this much. This is I only, integral 0 to 1, etc. This is this area only. So the total area is 4 into this answer, mind it. The total answer is 4 into this much. That's all. It's a very good problem. Note it. X square is equal to y, x square is equal to minus y, and y square is equal to 4x minus 3. 3 parabolas. Find the area bounded between those 2 parabolas. It is not an easy matter. You must be able to know the nature of the graphs and their intersection. First of all, you have to look at the region, isn't it? For which region we are supposed to have the area? You have to look at the region. Let us go through the graphs. We are happy. X square is equal to y and x square is equal to minus y you have drawn. And the thing is there, y square is equal to 4x minus 3. Y square is equal to 4x minus 3. What to get it? This is the parabola. Of course, I believe that they do meet here. This area plus this area gives us the correct area. So we must know the points where they do meet. What are the points? No doubt these two met at origin and by eliminating and solving you can see that 1 comma 1 and 1 comma minus 1, this is 1 comma 1, this is 1 comma minus 1, yes, 1 comma 1 and 1 comma minus 1. No doubt x square is equal to y and this, where do they meet? 1 comma 1. X square is equal to minus y and this, where do they meet? 1 comma minus 1. Very simple to look at. Okay, well my dear, here it is quite easier to have the area along y-axis. Let us do that. Why? Because if you find the area along y-axis from 0 to 1, this area, it is enough to find this particular area. 2 into this area gives the total area. Why? Because by symmetry about the axis, symmetry of the curves, we see that this area and this area are one and the same. Therefore, it is just enough to have this area. Of course, we double it after finding it to get the total area. Okay, in that business, let us first have required area is two into integral 0 to 1. Come on. In this one, that is, we are supposed to find this area. If you look in this corner, this curve lies in the upper position. What is this curve? Y square is equal to 4x minus 3, isn't it? From that, you find x, y square plus 3 by 4 minus. Now we find the curve, this curve. What is this curve? This curve is x square is equal to y, isn't it? So x is equal to root y in the first quadrant minus root y dy. And don't forget to put 2 here. So this is 2 into y square plus 3 by 4. 1 by 4 into, for y square it is y cube by 3 plus 3 it is 3y between the limit 0 to 1 minus, for root y, what is the integral? 2 by 3 into y root y between the limit 0 and 1. 0 and 1. Well done. So it is 2 into 1 by 4 into, come on friend, if you put 1 by 3 plus 3 you have, if you put 0 it is 0, if you put 1 it is 1, otherwise it is 0, hence it is 2 into 1 by 3 plus 3, what is that? 10 by 3 by 4, isn't it? Into 1 by 4 minus 2 by 3. Minus 2 by 3. Okay. So this is 2 into 10 by 4 is nothing but 5 by 2. 5 by 6 minus 2 by. Get it simplified. 5 by 6 minus 2 by 3 is nothing but 4 by 6. 5 by 6 minus 4 by 6 is nothing but 1 by 6. 2 by 6 is nothing but 1 by 3. Ultimately, the answer is 1 by 3, so many square units. Let us look at the next question. A region has been defined directly in that theoretical model, that theoretical approach. Set of all ordered pairs x, y such that x square plus y square less than or equal to 1 less than or equal to x plus y. What does it mean actually? That what is the region required? The interior part of the circle x square plus y square is equal to 1 and x plus y greater than or equal to 1. What is meant by that? You draw the line x plus y is equal to 1 and the region above that line is required. Let us try to represent this region graphically. How can it look? Let us see. What is the equation of the circle? X square plus y square is equal to 1. Well, this is origin. What is this point? 1, 0. What is this point? 0, 1. Well, what is the straight line given? X plus y is equal to 1, isn't it? X plus y is 1 means its x-intercept is 1, y-intercept is 1. Hence, of course, this is the required line. So, this is x plus y is equal to 1. This is x square plus y square is equal to 1. What is the area required? This is the area required. Why should you shade the upper part? Why don't you come to the lower part? You see, x plus y greater than or equal to 1. That is required. Please observe the data, the hypothetical condition of the region. X plus y greater than or equal to 1. Therefore, that shaded area is required. Okay. Let us use the simplest way. Look here. This is x square plus y square is equal to 1. Symmetric about both x-axis and y-axis because it contains both even parts of x and even parts of y. So, this area, this area, this area, this area, all the areas are same. So, this particular part is 1/4 of the total area of the circle, isn't it? Now, try to put the required step. Look here. Required area is equal to 1/4 of area of the circle. Area of the circle. What is meant by 1/4 of area of the circle? This entire area will become minus area of triangle OAB. Does it serve the purpose or not? Let me call this point capital A, this B. You just observe. 1/4 of the area of the circle, this entire part, minus area of the triangle. Remaining part is the required region, isn't it? You need not use integration at all. You can read the answer. Well, what is the area of the circle? 1/4 into pi r square. What is the radius? 1. Minus area of the triangle OAB. You see, this distance is 1, this distance is 1. What is the area? And it is a right angle triangle, you know, between x-axis and y-axis. We know that it is a right angle. Well, half into area of the triangle is half into base into height, half into 1 into 1, that is half. Well, this is pi/4 minus 1/2, so many square units. That's all. You observe how simple it is. Yes, that is the required area. Follow it. This is the next question before us. The area below the line it is available on the board. Please follow it carefully. The area below the line y is equal to x plus 1 and bounded by x square plus y square minus 4x minus 6y minus 19 is equal to 0. You observe. It is surely a circle. Let us understand the nature of the circle, its center, its radius, its location on graph paper, everything. Because we should know the intersection of this circle and that line, then only we will be able to locate the region. We will be able to find the limits of integration, thereby getting the answer. So, for all these things, we need to have the points of intersection of this circle and the line. Let us study. What is this circle? It is x square minus 4x plus 4, y square minus 6y plus 9 is equal to 19 is brought this side already, plus 19. Extra I have added two constants, 4 and 9. 4 plus 9 is 13. 13 you add here also, so that it is x minus 2 whole square plus y minus 3 whole square is equal to 32, isn't it? We can easily understand the nature of this circle. It is the circle with center 2, 3 and radius root 32, that is 4 root. Astonishingly, the center 2, 3 lies on this line. You can observe. Y is equal to x plus 1, isn't it? Is a circle with center 2, 3. Observe carefully. This 2, 3 lies on this line. Implies y is equal to x plus 1 is a diameter. Isn't it? Is a diameter. Why? Why do you believe that? Since 2, 3 lies on y is equal to x plus 1. It's very simple. Come on, tell me. This is the circle. This is the diameter. Area below the line and bounded by this means. What does it mean? It is just nothing but half the area of the circle. Or area of the semicircle below the diameter. Whatever you like it. Therefore, a required area is equal to half into area of the circle. Half into area of the circle. What is the formula for area of the circle? Pi r square. What is r square? It is 32. Is readily available. Hence it is half into pi r square. So it is 16 pi. So many square units. Sometimes such things happen which offer no strain or no stress to us to have the answer. We have not used any limits of integration, or even integration we did not use. So wherever equations are given like that, please follow the nature of the equations. Here we should feel happy because we could recognize that this is the diameter. If it is not a diameter, what should happen? Then you must find these 2 points of intersection, and from this point to this point, equation of the curve minus equation of the circle dx, that gives you. Of course we can do, we don't say that we cannot do, we do. But without doing all those things, we are able to have the answer directly. What is the answer? 16 pi. So many square units is the right answer. So observation is very, very important to say that we could have touched this problem. Follow it. The next problem before us is, there are 2 famous functions, y is equal to log x and y is equal to log x whole square. Y is equal to log x and y is equal to log x whole square. Of course it is to the base g, no problem, it is to the base g. I mean to say ln x and ln x whole square. What is the area between them? What is the area bounded between them? That is the next question. Well, first of all, where do they meet? It is essential. Log x to the base e and y is equal to log x whole square meet at log x is equal to log x whole square. Log x whole square minus log x is equal to 0. Log x into log x minus 1 is equal to 0. If this is 0, x is 1. If this is 0, log x is 1 means x is equal to e. Well, we could have noted these are the points of intersection of these 2 curves, and between these 2 only the area bounded between them is to be found. Well, x is equal to 1 and x is equal to e. So what are the points of intersection? 1 and e. 1 and e. Okay, let us have the required area? Well, required area is equal to integral 1 to e. Now you have to understand, log x or log x whole square, which is generally greater. Between 1 and e, we are to take log x minus log x whole square dx. Yes, log x minus log x whole square dx. Now it is our duty to know the integral of log x and the integral of log x whole square also. Of course, by using integration by parts only, you can do that. This is the required area. For log x, we know that the integral is x log x minus x, or x into log x minus 1. For log x whole square, we are not that much of awareness. Let us derive that separately. Integral of log x whole square is into 1 dx. So log x whole square into x minus integral of 2 log x by x into x dx by using integration by parts. So it is x into log x whole square minus 2 log x. What is 2 log x? 2 into x into log x minus 1 plus 6. That's the answer. Therefore, we use it. This is equal to, for log x, it is, what is that? X into log x minus 1 between the limits 1 to e minus log x whole square. What is the answer? X into log x whole square minus 2x log x plus 2x between the limits 1 to e is equal to, first of all, for this one, you see, this is a separate one. To have log x whole square on this part, we could have derived it at that place. If you put e, log e is 1, 1 minus 1 is 0, 0 into anything is 0, 0. If you put 1, log 1 is 0, 1 into 0 minus, if you put 1, 1 into 0 minus 1 is minus 1. Minus, now take e in the place of x, e into log e whole square, log e is 1, 1 square is 1, minus 2e into log e is 1 plus 2e. This is all the value when e is substituted. Now you put 1, what happens? Log 1, 0, 0 into anything 0, log 1, 0, 0 into anything 0, plus 2, hence it is 2 only. Here is again plus 2e and minus 2e will go away. This is equal to minus of minus 1 is 1 minus e, minus of minus plus 2. Totally it is 3 minus. Understand it? Mind the steps. Keep them in your mind. The next question is, find the area bounded by the curve y is equal to x into x minus 1 into x minus 2 and x-axis. That is the question. We should feel very happy because this polynomial is given in terms of a product of factors. Product of factors. By applying the scheme of signs on graph paper, you look here. This meets x-axis at 0, 1 and 2, isn't it? 0, 1 and 2. The larger number is 2. Positive, negative, positive, negative. Hence, there are two loop type graphs, parts of the graph are being observed. So the required area is integral 0 to 1 y dx plus integral 1 to 2 minus y dx. because here y is negative, and to have the area we are supposed to take mod y, isn't it? Okay, so required area is, first of all, let us try to simplify y. This product is x square minus 3x plus 2. So the entire product is x cube minus 3x square plus 2x. This is your y. Required area is integral 0 to 2 mod y. That can be split as integral 0 to 1 y dx plus integral 1 to 2 minus y dx. Because there y is negative, hence mod y is minus y. Okay, integral 0 to 1 x cube minus 3x square plus 2x dx plus integral 1 to 2 minus y. What is that? 3x square minus x cube minus 2x dx. Okay, so the answer is x to the power of 4 by 4 minus 3 into x cube by 3 plus 2 into x square by 2 between the limit 0 to 1 plus, for 3x square the integral is 3 into x cube by 3 is nothing but x cube minus x to the power of 4 minus x square between the limits 1 to 2. Integral of 2x is x square, of course. Well, this is therefore, if you put 1 by 4 minus 1 plus 1. If you put 0, everything is 0. Everything is 0. Plus, if you put 2 cube is 8 minus 2 power 4 is 16. 16 by 4 is 4 minus 2 square is 4. If you put 1, what happens? 1 minus 1 by 4 minus 1. What will be the remainder here? 1 and 1 will go away. This is 1 by 4. What about this? Minus 4 minus 8 plus 8 go away. Here 1 and 1 will go away. Minus of minus 1 by 4 is 1 by 4. 1 by 4 plus 1 by 4 is half so many square units. Is the right answer. The plus point here in the problem is y has been given as a product of linear factors, so that by applying the scheme of signs we are able to know the region where the function y is positive and where the function y is negative. Thereby we are happy to locate the limits of integration properly. That gives you the answer. The next question before us is, it is available on the board. Look at that. Set of all ordered pairs x, y such that y square less than or equal to x. What do you mean by y square less than or equal to x? Y square is equal to x parabola will be like this. Less than or equal to means interior part. So that is to the left of this concave part. Like this. And x square plus y square less than or equal to 2. What does it mean? It is the interior of the circle. X square plus y square is equal to 2. Well, it is very clear, evident that a circle and a parabola are involved in the graph. Okay, to trace, to notice the correct limits of integration, you must know the graph, the nature of the graph. Look here. Let this be the circle x square plus y square is equal to 2. This is the parabola y square is equal to x. This is the circle x square plus y square is equal to 2. Y square is equal to 2. And surely the center is origin. Therefore, This is x-axis, of course, which is the axis of the parabola also. Automatically this point is root 2 0. Why should it be? Why should it be? Because the circle is with radius root 2 units, isn't it? X square plus y square is equal to root 2 whole square. Hence the radius of the circle is root 2. Hence this point is root 2 0. Moreover, you need to have this point to have the area properly. Okay. Given curves are y square is equal to x and x square plus y square is equal to 2. They do meet at, where do they meet? X square. For y square is equal to x, for y square you put just x minus 2 is equal to 0, isn't it? So x plus 2 into x minus 1 is equal to 0. X plus 2 into x minus 1 is equal to 0. So if x is equal to minus 2, what happens? The curve do not enter into the negative part. So this is not possible. So what should happen? X is equal to 1. Therefore, x is equal to 1, y is equal to 1. Automatically this point is 1, 1. 1, 1. Well, let us draw an ordinate here like this. Well, my dear, let us have a proper plan to have the area. My plan is, I first find this area. I next find this area. And by the symmetry of the curves, this area is exactly equal to this area. Actually speaking, this total area we require. The interior of the parabola and interior of the circle, those two meet at this region only. Therefore, we need to have this area. We need to have this area. And my plan is, let us first find these two areas first. The sum of these two areas is half of the total required area. So we find this area and double that to get the required area. This is the plan of action here. Now we should get ready to have the integration concept to find the required area. Well, so the requirement has been obtained. That point is 1, 1. Hence they do meet at 1, 1 is one of the points of intersection. Well, I like to remove this to have the calculation part. You please follow this. Required area is equal to 2 into integral 0 to 1. Come on, from 0 up to 1. Here we are moving under the curve. What is that curve? Parabola or circle? Parabola. What is the equation of the parabola? Y square is equal to x, and so y is equal to root x. In the first quadrant it is root x dx plus, now 1 to root 2. From 1 up to root 2 we move under the curve. What is that curve? Circle. What is the equation of the circle? X square plus y square is equal to 2. So y square is equal to 2 minus x square. But my dear friend, we should have only y, isn't it? 2 minus x square. So what is the total answer? Let us try to get it. This is 2 into, what is integral of root x? 2 by 3 x root x. 2 by 3 into x power 3 by 2, that is x root x between the limits 0 to 1. Plus root of 2 minus x square, integral 0 to a, root of a square minus x square is a square pi by 4. We could have had already a standard result. According to that, it is 2 pi by 4, that is pi by 2. If you remember it, well and good. Otherwise, do it. What is that? What is the integral? What is the integral actually? x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a. A is root 2. Between the limits 1 to root 2. Previously we have thought of using a square pi by 4. That formula is valid when and only when the integral is 0 to a. It is not 0 to a. You must do it. Okay, right. This is equal to 2 into. If you put 1 root 1 is 1, 2 by 3 into 1 is 2 by 3, plus, look here, root 2. If you put root 2 whole square is 2, 2 minus 2 is 0, 0 into anything is 0. 2 and 2 will go away. Root 2 by root 2 is 1. Sine inverse 1 is pi by 2. Minus. Now, you put 1. 2 minus 1 is 1. Root 1 is 1. So, it is 1 by 2. Plus, if you put 1, sine inverse 1 by root 2. Sine inverse of 1 by root 2. What is that? Pi by 4. Pi by 4. Okay. So, this is 2 into. This is 2 by 3. Pi by 2 minus pi by 4 is plus pi by 4 minus 1 by 2. 2 into 2 by 3 is 4 by 3. 2 into half is 1. 4 by 3 minus 1 is 4 by 3 minus 1 is 1 by 3. So, the answer is 1 by 3 plus pi by 2. I think you could have followed. 2 by 3, 2 into 2 by 3, 4 by 3. 2 into half, 1. 4 by 3 minus 1 is 1 by 3. 1 by 3 plus 2 into pi by 4 is pi by 2. And the answer is 1 by 3 plus pi by 2. This is the beauty of the problem. Observe it carefully. The next problem is the area bounded between x square plus y square is equal to 2 and x square plus 4y square is equal to 4 is. This is the task before us. The area that must be evaluated is that. We try to understand the nature of the two curves here. One is a circle, of course, x square plus y square is equal to 2, centered at origin and radius root 2 units. And the other, of course, it is an ellipse. You can easily observe that. That is x square by 4 plus y square by 1 is equal to 1. So, it is an ellipse, the length of whose major axis is 4 units and that of minor axis is 2 units. That is, A is 2 and B is 1. There has been certain area involved between these two. That area we are supposed to have. Let us observe the diagram first. This is x-axis, this is y-axis. The radius of the circle is root 2, hence this is the point root 2 comma 0. The ellipse is x square by 4 plus y square by 1 is equal to 1, hence a square is 4, therefore a is 2, hence this point is 2 comma 0. Minor axis is 1, so this is 1, 0, 1. This is 0 comma root 0 comma root 2. Good. We require this area. Well, first of all, let us note where the two curves meet. Yes. What are the two curves? X square plus y square is equal to 2 and x square plus 4y square is equal to 4 meet at x square plus 4 In the place of y square, I'm writing 2 minus x square is equal to 4. So that it is x square plus 8 minus 4x square is equal to 4. So 4 is equal to 3x square, isn't it? X square minus 4x square is minus 3x square. It goes that side so that it becomes 3x square. 8 minus 4 is 4. So x square is equal to 4 by 3, and x is equal to x square is equal to 4 by 3, and x is equal to plus or minus 2 by root 3. X is equal to plus or minus 2 by root 3. This point here x coordinate is 2 by root 3, and here it is 2 minus 2 by root 3. Here it is 2 by root 3 and it is minus 2 by root. Therefore, let us have an ordinate here. This particular point is, this is 2 by root. X is 2 by root 3. If you put x is equal to 2 by root 3, what happens to y? Of course, it is not needed. Actually speaking, it is not needed. The x coordinate of this point is 2 by root 3. Now, you try to have the plan perfectly. You shared this region, this area plus this area. The sum of these two areas is 1/4 of the total required area, isn't it? 1/4 of the total required area. Okay, right. And we should know this point. The x coordinate of this point is 2 by root 3, you know. This distance is 2 by root 3. Okay, we could have had the plan. What is the plan? We find this area and have the sum. The sum of these two areas is 1/4 of the total required area. That is, we first of all find these two areas, find their sum and multiply it with 4, of course, to get the required area. That is the plan here. We are now ready to implement that plan. Yes, please follow this. I would like to remove this. Area of the shaded region is equal to area of the shaded region is equal to, come on friend, the very first part, integral 0 to 2 by root 3, integral 0 to 2 by root 3. At this region, in this region, we move under the curve. What is that curve? Ellipse or circle? Ellipse, isn't it? Y of ellipse dx plus integral 2 by root 3 to root 2, 2 by root 3 to 2 to y of circle dx. Isn't it? Yes, of course. This is equal to integral 0 to 2 by root 3. What is y from the ellipse? Come on. 4y square is equal to 4 minus x square. So y square is equal to 4 minus x square by 4. So root of 4 minus x square by 2 dx plus integral 2 by root 3 to root 2. Y from the circle, come on, it is just root of 2 minus x square dx. 2 minus x square dx. Okay, and it is of course a lengthier procedure to have the formula for this, and just like nothing but that, there is no difficulty. Okay, we are to use the formula for these two also. Come on, what is the formula for integral root of a square minus x square? X by 2 into root of 4 minus x square plus a square by 2. A square is 4, a square by 2 into sine inverse x by a between the limit 0 to 2 by root 3 plus, what do you say about that? What is here? x by 2 into root of 2 minus x square plus a square by 2, that is 2 by 2 into sine inverse x by a. What is a? Root 2. Between the limits 2 by root 3 to root 2. And this is the process which is remind that you have to calculate. The only calculatory part is just remained. Follow the diagram. I need to remove it so as to save some space, of course, for the calculatory part. Half into. First of all, take 2 by root 3. 2 by root 3 by 2 means 1 by root 3. 2 by root 3 whole square means 4 by 3. 4 minus 4 by 3, 8 by 3. Root 8 by 3. Root 8 by root 3 plus 2 by root 3. 2 by root 3 by 2 is 1 by root 3. Sine inverse 1 by root 3. 2 sine inverse 1 by root 3. And then you put 0. If you put 0, this is 0 and that is 0, there will be nothing at all to calculate. Stop. Plus, what is the case with this? If you take x is equal to root 2, root 2 whole square is 2, 2 minus 2 is 0, this is 0. Root 2 by root 2 is 1, sine inverse 1 is pi by 2. Therefore, 0 plus pi by 2 minus, now 2 by root 3. If you put 2 by root 3, 2 by root 3 by 2 is 1 by root 3. And 2 minus 2 by root 3 whole square. What is 2 by root 3 whole square? 4 by 3. 2 minus 4 by 3. 2 minus 4 by 3. 2 by 3. Hence it is root 2 by root 3, isn't it? 2 minus 4 by 3. 6 minus 4, 2 by 3. Okay. Plus 2 and 2 will be cancelled. 2 by root 3. 2 by root 3 by root 2, isn't it? 2 by root 3 by root 2. That is root 2 by 3 plus sine inverse root 2 by 3. Isn't it? That is the answer. Of course, even after simplification, sine inverse something will be there. No problem. It is root 8 is 2 root 2 by 2 into 3, 6 plus 2 sine inverse 1 by root 3 plus pi by 2 minus root 2 by 3. Root 2 by 3 minus sine inverse root 2 by 3. This is 2 by 6 is root 2 by 3 and root 2 by 3, they go away. That gives you the answer. 2 sine inverse 1 by root 3 plus pi by 2 minus sine inverse root 2 by 3. Hey, hello friend, this is the shaded area, not the complete area. This is just the shaded area. So what is the complete area? 4 into that much gives you the total area. So the actual answer is 2 into sine inverse 1 by root 3 minus sine inverse root of 2 by 3 plus pi by 2 is the area shaded in the diagram, and hence the total or the required area is 4 times of that is the answer. 4 times of that answer is the correct answer. This is the matter. You see, as and when we come across intersection of two standard curves, such bulkier calculation generally comes. At times, the problem might be very simple also. It depends on the nature of the graph or the points of intersection. Yes, that is the answer. The next problem, the area bounded between y is equal to 2 minus x square and y cube is equal to x square. The area between them. Observe the two graphs. One is y is equal to 2 minus x square. Of course, it is a parabola opened downwards. opened downwards, that is towards negative x-axis, and y cube is equal to x square. It passes through the origin, of course. Let us observe the points of intersection. These two curves meet at 2 minus x square whole cube is equal to x square, isn't it? Y cube is equal to x square. So if x is 1, 2 minus 1, 1 cube is 1, 1 square is 1, satisfied. If x is minus 1, then also satisfied. That is x is equal to plus or minus 1. Therefore, they do meet at plus 1 and minus 1. Okay, what is the required area? How to get it shaded? Y is equal to 2 minus x square. Where does it meet x-axis? 2 minus x square is equal to 0. X square minus 2 is equal to 0. X is equal to plus or minus root 2. Hence, like this. Minus root 2, 0. This is plus root 2, 0. And it meets y-axis at 2, 0, comma. This is the nature of this one. And y cube is equal to x square. It will be like this. Therefore, the required area is this. That is, of course, the required area. Clearly, this is 1, 1, and this is minus 1, 1. 1, 1, minus 1, 1. Good. So, what is the required area? What is the required area? From minus 1 to 1, we are supposed to integrate, isn't it? Shaded area is equal to integral minus 1 to 1. What is the curve which lies at the upper part? Parabola or the other curve? Parabola. Y is 2 minus x square minus the lower part. Y cube is equal to x square, isn't it? So y is equal to x power 2 by 3 dx. X power 2 by 3 dx. This is equal to, surely this is an even function. It can be taken as 2 into integral 0 to 1, 2 minus x square minus x to the power of 2 by 3 dx. Well, 2 into integral of 2 is 2x minus x cube by 3 minus x power 2 by 3. 2 by 3 plus 1 by 2 by 3 plus 1. What is 2 by 3 plus 1? 5 by 3. X power 5 by 3 by 5 by 3. Hence it is 3 by 5 x to the power of 5 by 3 between the limits 0 and 1. Hence it is 2 into 2 minus 1 by 3 minus 3 by 5. That's all. If you put 0, everything becomes 0. Isn't it? So that, what is it? It's equal to 2 into, what is the LCM? 15, 30, minus 5, minus 9. 9 minus 5 is, minus 5 minus 9 is minus 14. 30 minus 14 is 16. 2 16s are 32. Hence the required answer is 32 by 15. So many square units. So many square units. That's it.